balancing of reciprocating mass, right? So balancing of reciprocating mass. So what is reciprocating mass? So reciprocating mass typically have in IC engines, right? So IC engines, whatever you have seen in IC engines, right? It's like there are parts like suppose this is cylinder head, then there will be a piston pin here. This is cylinder, and this is a cylinder. Crankshaft, right? Crank, and here connecting rod. So this is a small end and this is a big end, right? So here there is a motion, is a rotary motion, and this motion is a reciprocating motion, or this motion is a reciprocating motion. So when there is a reciprocating motion, here rotary motion, generally we have learned balancing only for this rotary motion, but the effect of rotary is converted into reciprocating, and how the balancing will be there, that we need to understood, right? Suppose मैं इसको थोड़ा सिंप्लीफाई करके समझाता हूँ. Suppose you have a slider crank mechanism, you know slider crank mechanism. This is slider, this is axis, connecting rod, and crank. Okay, so this is suppose crank O, this is crank shaft C, this is piston, balancing mass, right? This is our crank radius and this is our length of connecting rod. So crank will move like this in rotary direction, this will move in reciprocating direction. Okay, so here we can see the force equation. What is the force equation? The total force is equal to mass into acceleration. So mass, what is the acceleration of this reciprocating mass? So acceleration, in your previous semester you have understood, like this is F, acceleration, or we can say A is acceleration, is equal to omega square r cos theta plus cos 2 theta upon n, right? R is a crank radius, so that is resemble to this. Theta is the angle, this is the angle, right? And n is a obliquity ratio. So what is obliquity ratio? Obliquity ratio means is length upon connecting length of connecting rod upon crank radius. So if we put acceleration over here, so Fc is the inertia mass, will be mr omega square cos theta plus cos 2 theta upon n, right? So this will be something mr omega square. If you multiple in the bracket, this will be cos theta and this will be mr omega square cos 2 theta upon n. So here this will be represented as a Fp and Fs, where Fp is a primary unbalanced force, Fs is a secondary unbalanced force. Okay, so here you need to do by both way. You need to also balance primary as well as secondary unbalanced force also, right? So let us deep dive something. There will be one questions come related to this, like why we need to do only partial balancing of reciprocating mass. Partial balancing of reciprocating mass. So again the same, like this is a cylinder, this is a crank, right? This is a crank R, this is connecting rod, this is C, right? Let us assume, suppose M mass. M mass is here with a radius of r and moving with velocity omega. So what will be the centrifugal force at this instance? It will be in radial direction. The centrifugal force will be mr omega square. And here we have defined this angle is a theta. So in this direction, the force component of this Fc will be Fc cos theta. And that will be Fc is a mr omega square cos theta. Right? So this is in the line of action. Whatever reciprocating balancing will be there, this will be in the line of action. And this is only the component of primary unbalanced force. Right? So by this way, you are not going to balance the secondary unbalanced force. So this will represent as a, we are doing only balancing of this primary unbalanced force, and that's why it is known as a partial balancing. Suppose to unbalance this, what we need to do, the same mass, suppose mb, I am placing over here with rb radius, and here this angle is theta only. The angle is same. So centrifugal force will be mb rb omega square, and the cos component will be here, and that will be mb rb omega square cos theta. And to balance this Fp centrifugal force, you need to equate both this. So m bar omega square cos theta should be equal to mb rb omega square cos theta. Theta omega square will be cancelled. So m into r is equal to mb into rb. So this will be the balancing condition over here, right? So here we are, for this balancing mass, the one component will be also over here, that will be mb rb omega square sine theta, and here this component is not going to balance anything, right? This is the perpendicular to line of action, right? So that's why the partial balancing, so this reflect as a partial balancing, right? So here mr should be mbrb, right? And to resolve this, we need to add one factor, that is mbrb is equal to, should be cmr, where c is a partial factor, c is a balancing factor, right? So what is the value of c? C will be always less than 1. C will be always less than 1, right? So what will be the unbalanced force will be here? So total unbalanced force will be, suppose in horizontal axis, what will be the horizontal axis? Here in the horizontal axis, this is mr omega square and this is mb rb omega square, right? So this is mr omega square cos theta minus mb rb omega square cos theta. But mbrb is equal to cmr, we are doing partial balancing, so mr omega square cos theta minus cmr omega square cos theta, right? And this will be, omega square will be common, so omega square cos theta will be in bracket, so it will be, and yeah, so mr and mr also will be constant. So let us remove this. So mr omega square cos theta will be common, so 1 minus c. So this will be primary horizontal balancing. What will be the vertical component will be? Vertical component, there is only one component, that is a, what is the component? mb rb omega square sine theta. So this is horizontal, this is vertical. How we will define the final one? The resultant unbalanced force, right? So resultant will be under root of fh square plus fv square. So what is fh? Fh is a under root of 1 minus c, right? fh square, na? So 1 minus c square m square r square omega, yeah, you can do like this also, mr omega square cos theta whole raised to square plus what is the final one? This fv is equal to mb rb omega square cos sin theta raised to square, right? So what is common? mr omega square, but this is cmr na? C square mr omega square, so c. So the equation will be what? mr omega square will be common in the bracket, 1 minus c raised to square cos square theta, but here the c square will be remaining and this will be sin square theta, right? So this is the final equation for unbalanced force in reciprocating mass. So this is the concept. Thank you.